When children are born, they inherit traits from their parents. Similarly, in code, a class can inherit traits from another class. This is called code inheritance, and in practice, it's commonly referred to as subclassing. Inheritance describes the sharing of traits between a parent and child class. The parent class refers to the existing class, while the new class that inherits all properties and methods from the parent is called a child class. In short, code inheritance is the process of subclassing a class from another class. You can think of subclass as the common verb for class or object inheritance in programming. Over the next few minutes, you'll discover how to use subclassing in Swift to create a child class that inherits traits from a parent class. Suppose you're developing a gardening game. In this game, you need to program spinach, broccoli, and carrot classes. Spinach, broccoli, and carrots are vegetables. Knowing this, you can make these classes inherit vegetable traits by subclassing them as a vegetable. This means that you don't have to rewrite the common code between classes, which reduces the overall effort required to maintain your code. To demonstrate subclassing, let's explore how spinach, broccoli, and carrots can be programmed to sing a special vegetable song for the gardening game. First, I create the parent class by defining a new class called vegetable. Then, I add a constant called primary color with its value set to green. Next, I create a method called sing that prints I'm an awesome vegetable. And now I have a vegetable class that has a property and a method. With the vegetable class available, I can now create spinach, broccoli, and carrot classes that inherits the property and method of vegetable. To do this, I'll use the Swift syntax for subclassing. I start by inserting the keyword class, followed by the child class name, in this case spinach. Next, I insert a colon followed by the parent class vegetable, and then I add curly braces. I'll do the same for broccoli and carrot. And now I have three new classes, spinach, broccoli, and carrot, which are all child classes of the vegetable parent. To demonstrate that spinach, broccoli, and carrot inherit properties and methods from vegetable, I'll initialize each child class, print its primary color, property, and call the sing method on it. To do this, I create three new constants for spinach, broccoli, and carrot, and set the values equal to their respective class. Next, I print each primary color. And finally, I call the sing method on spinach, broccoli, and carrot. When I run the code, the output from each class is the same. All the vegetables print green and sing the same I'm an awesome vegetable song. But what if I want to differentiate a child from its parent class? To do this, I can override the parent's properties and methods in the child class. You can think of properties and methods override as altering the parent class DNA for a child class. A common use case for altering the DNA of a child class is when you want to keep a set of properties and methods the way they are. However, you want to differentiate one or a few properties or methods for the child class. If you want a child class to have a different property value than its parent, you can override the parent property. For instance, I'd like to override the primary color property of the carrot class from green to orange. I insert the override keyword to declare the intention of replacing the primary color value of the parent class with orange. With the newly added code, the compiler greets me with an error that reads, "Cannot override with a stored property primary color." This is because I cannot override a stored property, but I can override a computed property. So to demonstrate this, I change vegetable's primary color stored property to a computed property. Now I can successfully override the primary color property in the carrot class. When I run my code, the console log prints orange. It is clear that the carrot class overrides the primary color of the parent class. Let's try something similar with broccoli. I want broccoli to sing a different song. To do this, I override the sing method inside the broccoli class. Then, inside the override sing method, I invoke the parent method by using the super keyword, followed by a dot and the desired parent method. When I execute my code, I can observe that the broccoli class sings a 3-line song in the console log. And there you have it. You should now be able to demonstrate how subclassing and inheritance enable you to share properties and methods between parent and child classes. You should also be able to differentiate a child class by overriding its parent properties and methods.